Okay, section 9.4, it's just titled coin, but we're looking at some word problems dealing with coins. So some of these are classic coin problems, and they can usually be set up using a system of equations. One involving the number of coins, so that would be one of our equations, and the second equation involving the monetary value of the coins in cents. So remember the decimal value of each coin. A penny is 0.01, a nickel is 0.05, a dime is 0.10, a quarter is 0.25, half dollar 0.50, and a gold dollar 1.00. So let's go ahead and read through this first problem. You have dimes and quarters in your pocket. There are 12 coins. I'm going to go ahead and circle that 12. And they total $2.25. Write and solve a system of linear equations to find the number of dimes and the number of quarters. So you could probably try to guess and check to figure out how many dimes and how many quarters you have. But our instructions have instructed us that we need to write a system of linear equations for these. So we have dimes and quarters. I'm going to use the little braces just to write my two equations. So remember, one of the equations deals with the total number of coins, and the total number of coins is 12. So that means that the number of dimes plus the number of quarters, and use a large Q, is equal to 12. The second equation is dealing with the monetary value. So a dime is worth 10 cents. So let's put 0.10 in front of dimes, plus a quarter's value is 0.25, so 0.25 Q is equal to this total amount of money that we have, which is $2.25. Okay, from this point, you could go ahead and choose which method you would like to solve this system of equations. Maybe you prefer substitution, so you might solve the top equation by D or Q, or you might prefer elimination, since this is set up, the equations are set up with the variables lined up. We do have these decimals, though, that we really need to be careful on. I'm going to go ahead and use elimination. So let's say I wanted to eliminate the dimes. This bottom has a coefficient of 0.10. Well, if I had the top D, if it had a coefficient of negative 0.10, then when I added, they would drop out or cancel out. So I am going to go ahead and multiply this top equation by negative 0.10 on both sides. So my new equation becomes negative 0.10D minus 0.10Q is equal to, you'll definitely want a calculator for this section, 12 times negative 0.1 is equal to negative 1.2. The bottom equation, I'm going to rewrite the exact same. Just being very careful with these decimals. Not leaving a decimal out. Now we can go ahead and add the two equations together, because when we add these two equations, the D's drop out, negative 0.10 plus 0.25Q results in 0.15Q, and then on the right hand side, negative 1.2 plus 2.25 results in 1.05. So you can see a lot of places where it's really easy to make a simple error. The last step would be to divide both sides by the number in front of Q. So let's go ahead and divide both sides by 0.15. So we already have the 1.05 up in the calculator. When we divide, we're getting hopefully a whole number, because we can't have a half of a quarter or a third of a quarter. So we just figured out that the number of quarters is equal to 7. So let's write our answers out. We have 7 quarters. Now the nice thing about these coin problems is there is an easy way to find your second answer. Out of the two equations, there's a simpler equation, that top equation. And if we substitute 7 in place of q, we have d plus 7 equals 12, which means we're simply subtracting 7 from 12 to get the number of dimes. So 5 dimes and 7 quarters. All right, let's take a look at this second example. You have quarters and dimes in your pocket. There are 21 coins that total $2.85. We're going to go ahead and write and solve a system of linear equations to find the number of quarters and the number of dimes. So we have quarters and dimes. The total number of coins is 21. Then the second equation, let's put this 285 on the right-hand side. And on the left-hand side, we're going to use the values for quarters and dimes. So a quarter is worth 25 cents, so 0.25 Q. And a dime is worth 10 cents, so 0.10 D. Now if I wanted to eliminate the Q's, notice the bottom equation has a 0.25 for the coefficient. If I had a negative 0.25 on this top equation, then we would be able to add the Q's and have the Q's cancel out. So let's multiply the top equation by a negative 0.25. So our new top equation is negative 0.25 Q minus 0.25 D, and we need to type in 21 times negative 0.25, and that gives us negative 5.25. Work really careful when you're solving these equations. It's easy to make a simple mistake, either between the negatives or adding these decimals together, which is why you can always double check on the calculator. So I kept the bottom equation the same. I'm now adding these equations together so that the Q's drop out. Negative 0.25 plus 0.10 is negative 0.15 D is equal to negative 2.4. So let's go ahead and divide by always the number in front of the variable. So we have negative 2.4 divided by negative 0.15. And that gives us 16. So we have a total of 16 dimes. And let's use this easy equation up at the top. So quarters plus 16 equals 21. Subtracting 16 from both sides, we get 5 quarters. All right, and the other nice thing about this is we could check this. 5 quarters, so 5 times 0.25 would be $1.25, plus 16 times 10 would be $1.60. So add 1.25 to $1.60, and we should get this total value on the right, which we are. Okay, number 3. Ethan has nickels and quarters totaling $2. He has 12 nickels and quarters. How many nickels and how many quarters does he have? So we have a total of 12 coins. So N plus Q is equal to 12. Now let's put the value of each coin. Remember, a nickel would be 0.05, a quarter is 0.25, and the total amount of money is $2. So I'm going to eliminate n's. So if I multiply this top equation by negative 0.05, that will help eliminate the n variables. So negative 0.05n minus 0.05q equals negative 0.6 or negative 0.60. I'm keeping the bottom equation the same. Adding these two equations together so that the n's drop out, we're left with 0.20q is equal to 1.4. Divide, and we are getting that the number of quarters is equal to 7. Using this top equation, n plus 7 equals 12, means the number of nickels is equal to 5.